All right, so we are talking about Quiz 2B. Quiz retakes. So people are asking about retakes. So it's half the points you missed. Usually they're due at the. Usually the retakes are all due at the very end of the semester. We may make this a 2-week time period or something, but I will give you advance notice before we do something like that. So you can make them up in the past. It's going to depend how many retakes we get. Doing these retakes all online is something completely new to us, so we're not exactly sure how everything is going to work. As I said before, a lot of this is new. It's going to take us a little while to figure everything out. It's going to take you a little while to figure out everything. That's why I'm very zen. And it's going to take me a little bit of time to figure everything out. So I'm asking you to be a little patient. All right. Yes. So there's a question about whether or not we didn't take the quiz on time. Can you still upload for half credit? The answer is yes. I don't know why this says quiz 2. I don't know why this says quiz 2B and not 2A. But that's easy to fix. Anything else? Wrong, bad. I also don't know why this thing is showing the title bar, which it shouldn't, and not the bottom of the page, which it should. Okay. All right. So yes. So if you miss a quiz, you can retake it for half the points, for half credit. Obviously, you missed all the points, so half the points you missed is half credit. If there's some reason, if you're gonna be late, you have an excuse, there's some real reason, please tell me in advance. I'm very flexible on due dates. If you tell me before the thing is due that you need a little more time. If after it, I tend to be a little less flexible. So if you ask me ahead of time, hey, I'm going to be, I'm going to be, at the playing for the football team, and you ask me ahead of time, I'm like, yeah, sure. If you don't, I'm kind of like, half the points you missed. So just for future reference. Okay, let's talk about this quiz. So I'm asking you for various limits here. There it is. And the first one is this thing. As x goes to negative infinity, and make sure that you keep your x's and y's straight, because it's very easy to get these backwards, right? As x goes way over to the left, what happens to y? Right? So this is 2, 4, 6. Obviously, this is 0 then. And as x goes way over here, what happens to y? Well, y is going to 0. As x goes, to the left there, I'm not sure which way that looked like to you. Yeah. As x goes way to the left, as x goes that way, as x goes that way, what happens to y? Y goes to 0. How do we feel about that? 1 to 5. Just what's going on as x goes to negative infinity. Let's see if I can do this. 6. Okay, so everyone seems to be pretty good about that. Hey, look at this. I got it. So there's no need for me to do a poll, right? I feel like it. There we go. I got it to work. Okay. So we feel pretty good about that. All right. Now, the second one here. There we go. The second one, the limit as x goes to negative 2. Well, as x goes to negative 2, can everyone see that this goes to 2 from the left and 2 from the right? So that means that it just goes to 2. And you all talked about that in peer leading. That was awesome. I don't know why this thing keeps coming up, but it does. This one, the limit as x goes to 0, well, as x goes to 0, right, from both the left and the right, y is heading to 6. So B and C, how do we feel about those? Are there any questions, by the way? Okay. So B is, as x goes to -2, you can see this. As x gets closer and closer to -2, what's happening here to y? Well, it's approaching 2 from this side. And then as x goes here, y approaches 2. All right. Yeah, so limits can exist at points where I'm undefined. That is correct. All right. And then from the left and the right around 0, that's fine. That exists. It's defined there, but it's also, that's the limit. Okay. So if I look here at f of 3, this one's a little trickier. So f of 3 equals 6. That's where it's defined. But the function approaches, as I come from the left, the function approaches 4. But when I come from the right, that's what that little negative it equals. Like. But when I come from the right, I've got 2. So how do we feel about that? D, E, and F. Oops. Together there. 1 to 5. How do we feel about that? Yeah, I do that all the time. So someone's saying that you flipped them, and yeah. It's easy to get a little lexistic about these things. I mean, dyslexic, so, you know. I do it all the time. It's also easy to cross your X's and Y's and get those backwards. All right. Now, here's the first one where it doesn't exist. And it doesn't exist here. The limit as this thing, right? So this is asking for a one-sided. Here, I'm asking for two-sided. And here, because 4 does not equal 2, at least not this week, these two limits don't go to the same place. How do we feel about that, G? The limit doesn't exist because the limit from the left and the limit from the right don't go to the same place. All right. All right. And this last one's the tricky one. This last one's like the thing that happened on. This thing is like that thing where I had. So this is like, think about the limit of sine of x as x goes to infinity. And what does sine of x do? It doesn't settle, right? If I look at sine of x, it never stops at a place. It just kind of oscillates between -1 and -1 and 1. So sine of x looks like this, right? And it doesn't matter how much I zoom out. If I keep going to infinity, it never settles on a value, right? It goes up and down and 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 up and down. It never goes to a single number. I mean, compare that to sine of x over x. Sine of x over x also oscillates, but it starts going towards 0 on from both directions, right? If I zoom in here on sine, If I zoom in here on sine of x, over x, it starts it oscillates, but it moves closer and closer to 0 with each oscillation. The extremes move closer and closer to 0. Whereas if I go to sine of x alone, it doesn't do that, right? It keeps oscillating between -1 and 1, and it does that forever. All right, so here the limit just doesn't exist. It just goes up and down and up and down and up and down and up and down and up and down forever. And that's a little tricky. How do we feel about that, 1 to 5? It never settles. All right. Well, the left side does. The left side settles, right? As I go to negative infinity, this goes to 0. Here, the right side never settles. Now, on sine of x, neither side settles. Yeah. All right. Okay. All right, well, let's look at this one. Let me show you how I did it. Let's blank it off. I mean, everyone's seen the answer, but let's actually run it through. All right. When it comes to these like infinity conditions, it's helpful if you think of infinity as a point. Let me show you what I mean by that. The first thing I'm going to do, x goes to negative infinity. As x goes to negative infinity, y goes to 2. Okay, that's what that means. I kind of think of that as a point. It's not really a point, but I think of it as a point. So I come over here to negative infinity, I go 2 up, and I just put an arrow there. The next one, this actually says that the point -2 minus infinity is on the graph, and -2 plus. -2 from the left and -2 from the right, and the x base, and then infinity. So -2 that way and that way. This says infinity -4 or positive infinity -4. So I come over here to positive infinity on my x, and I go down to -4. All right. This right here says that 1 right 5 is on the graph. Is that better? So now I'm going to go to 1 right 5. Okay. So here's 1 right. And here's 5. I'm going to put an open circle there with a right-handed tail. This is 1 left, -4. So I'm going to come down here. I'm going to go 1 left. I'm going to go down here to -4. I'm going to put a tail there. And then I've got f of 1 equals 3. That means that 1, 3 is on the graph. And now I connect my dots, left to right. I'll get to this in a minute. Put a little asymptote line here. Not required, but it just says that there's an asymptote there. I'll put a little one here too. Again, not required. Not required. Those asymptote lines are just to kind of guide me. All right. I'm going to be very careful not to violate my vertical line test. Oops. That's a tough one. Something like that. And then I'm going to come up here. Let's do something like this, something like this. Have a meet in the middle there. All right, and this last one, F is defined everywhere. I feel like defining it here. Not needed, but I just felt like it. All right, and then I'm going to check my conditions. I'm going to check my vertical line test. I'm good. So, is it the case that the limit as x goes to negative infinity is positive 2? Yes. Is it the case that x goes to negative 2, y goes to infinity in both sides? Yes, yes. Is it the case that the limit as x goes to infinity is negative 4? Yes. Is it the case that as x goes to 1 from the right, I go to 5? Yes. Is it the case that as x goes to 1 from the left, I go to negative 4? Yes, that's true. And is it the case that f of what equals 3? Yes. Is it the case that f is defined everywhere except maybe negative 2? Let's fill in some of these holes. Yes, yes. I might make a note. So these little things in orange are just notes for the graders I might make. All right. How do we feel about this 1 to 5? Does it matter if the tail goes up and down for D? And no, as long as it goes left, as long as it goes for D, the tail needs to go right. And for E, the tail needs to be on the left. I would put the arrow when it gets to infinity. It's a good thing. Can I violate that asymptote? What asymptotes can I not violate? It's a good question. So the question is, can I violate the asymptote at 2? Right. I can't violate the x equals negative 2 asymptote. Well, I sort of can. I can't like put a line there, but I can put a point on it if I feel like it. You just can't put any lines on it. But the horizontal asymptote, you can always violate that. I said that x is defined everywhere except maybe x equals negative 2. So that this point is completely optional. I didn't need it. There you go. The line for E. The limit as x goes to 1 from the left. So what are you saying here? The line for E There's not really a line for E. It just kind of comes up. It can't go right. It's got to go left. You could make it do something like this if you wanted to. This is valid. Here's another way of doing this. I could do that. That's just lazy. I'm happy with lazy. That's good. I get rid of this note then. All right, that meets my conditions, correct? I nowhere did I said that they say that it had to be continuous on these things, right? I could have a big giant jump for that. For G, can the line go up instead of down? Oh, no, because it's not. So for G here, you're really meeting condition B. So condition B says that both go up to infinity. Yeah. All right. And name one thing you found memorable from the last lecture or the class video. Last class or last lecture video. Figured out how to use... There we go. Okay, so so these are graded out of 20, and there are 22 points possible. So it's possible to get 110 on the quiz. There's 2 bonus points baked into this. Any questions? Other questions? Quiz retakes are the same questions, but the kicker is that I get to interrogate you to find out if you really understand it. The retake will probably be posted as soon as we make the rubric in Gradescope. Because remember, what I want to do when I copy Gradescope, I want it to also copy the rubric at the same time. So I haven't made the rubric in Gradescope yet, and when I make the rubric in Gradescope, I will make a new setting. So give us a day or two to do that. It takes us a little bit of time. Any other questions? Okay. All right, so how do we feel about this quiz 1 to 5 here? Let's see, multiple choice quiz as a whole. 1, 2, 3, 4, 5. Yes, so I did say you kind of need those. You need those arrows as you go off to infinity. And they're actually good. It says if you place the arrows first, it's actually easier. So I'm going to say yes, the arrows are required. I am also going to say that you should do the arrows first because it's I'm going to say yes, the arrows are required. I'm going to say that you should do them first. All right. You do not need a point for G. You do not need a point at x equals -2. You just had to make it. You couldn't just put the arrows, right? You actually had to do. You had to define the functions everywhere. Okay.